Hello students, welcome to e-learning, and today we are going to concentrate in this video on law of moments. So this is the lecture number 4 in Introduction to Engineering Mechanics. So please do subscribe the channel for the upcoming videos and the notifications. So firstly, before going to law of moment, we will understand exactly what is moment of a force. Already we have discussed this moment in the previous lecture number 3, and I would like to again describe this for you to understand the law of moment. Moment is nothing but the product of force and the perpendicular distance. So in the figure also you can find out the force is perpendicularly acting on this beam, cantilever beam, and the span is of L. So force into L is giving us the moment at A point. So moment of a force. By this basic understanding, we can easily understand the law of moment. So now coming to law of moment, you can see the picture here. A scale which is fixed on the pivot in the center is having the forces tied on left and right side. Force 1 is tied at some distance from the end of the scale, from the left side, and force 2 is fixed at the end of the right end of the scale. And force 1 is at distance 1. Okay, so consider this is distance 1 for force 1 from pivot, and distance 2 for force 2 from the pivot. When an object is balanced in equilibrium condition, they are saying it as at equilibrium condition. When the object is balanced in equilibrium, the sum of the clockwise moments is equal to the sum of anti-clockwise moments. It means if force 1 and force 2 are varying, but the distances are very, very important in making the scale or balancing the scale at equilibrium. So moment, indirectly it is nothing but a turning force moment. So what it is saying is force into perpendicular distance till the pivot. So moment we are going to take it at till the pivot point. So force 1 is pulling down the scale with perpendicular distance d1. So this is nothing but this force is going to pull it anti-clockwise or rotate this scale in anti-clockwise direction, right? Anti-clockwise direction. And force 2 is going to pull it in clockwise direction like this, correct? So the law of moment tells that when these two forces balance the scale at equilibrium, the sum of clockwise moments, this is one of the clockwise moment, and sum of anti-clockwise moments. Here there are only two forces acting, maybe there are 3-4 forces on the left and right side. So that time the sum of all clockwise moments, so this is only one force now, so this is one clockwise moment, and this is going to be a anti-clockwise moment, force 1 into perpendicular distance, right? So it will be equal. So how you can write it in the equation is force 1 into perpendicular distance d1, force pulling it down and its perpendicular distance till pivot is d1 is equal to force 2 into d2. So this is perpendicular distance again for force 2. So it will be equal. So moment, and this is nothing but what F1 into d1 is nothing but anti-clockwise moment is equal to F2 into d2 is clockwise moment. So anti-clockwise moment is equal to clockwise moment. So hope you got the concept. Thank you students, and for further notification please subscribe the channel, like, share and comment.